Okay, we are reviewing for our spring geometry final. This review is fairly lengthy, so I'm not sure how many videos I will make. So we'll just play it by ear. I'll get started and we'll go from there. Okay? All right. Number 1. Oh, I do want you to know that the final is very much like this review. So if you're good with this review, then you should be good with the final. All right, number 1, it wants to know the smallest side of triangle XYZ. So you find the smallest angle, and whatever side is all the way across from it, that would be your smallest side. So your smallest side is side XY. So the smallest side's across from the smallest angle, and the biggest side would be across from the biggest angle. So XZ would be the biggest. Okay, number 2. An equilateral triangle with side lengths of 7 is shown. What is the height of the triangle? Okay, so because it's an equilateral triangle, I know that all 3 sides have a length of 7. I know that every angle inside is the same, so that means this is 60 degrees, this one's 60 degrees, this whole angle 60, but it gets split in half. So we've got ourselves a 30, 60, 90 triangle. Okay, I can also assume that that's probably 3.5, but I could figure that out for a fact. Across from the 30, that's your x. Across from your 60, that's your x square root of 3. And across from your 90, that's your 2x. So since there's a number there, I'm going to put an equals between it and the 2x. Well, if I divide both sides by 2, then I get x to be 3.5. So that's exactly how long that piece is. Okay, so if x is 3.5 and across from the 60 is x square root of 3, then I get to put 3.5 right there in that x, and that makes your height 3.5 square root of 3. So I put the 3.5 in the x, recopy square root of 3. And there's our height. A little practice with the 30, 60, 90 triangle. You could have also done Pythagorean theorem, but I think this is much faster. Number 3. The hypotenuse of a right triangle, okay, it's a right triangle, measures 30 centimeters and one of its sides measures 18. What's the length of the unknown side? Okay, because it's a right triangle, then we can work with Pythagorean theorem. A squared plus b squared is c squared. Now, because the hypotenuse measures 30, I know the hypotenuse is always the c, so 30 goes into the c. And then it says that one of the sides measures 18. So it doesn't matter if the a is an 18 or if the b is an 18. I'm just going to put an 18 where the a is. And then I need to solve this equation for b. So, to get b by itself, the first thing I'm going to do is subtract the 18 squared. And then the b squared is going to drop. The equals is going to drop. I'm going to get my handy dandy calculator. And in the calculator, I'm going to type in 30 squared minus 18 squared. That makes 576. And then to make the squared go away, I square root both sides. And the square root of 576 is 24. So b, the unknown side, is 24. Now, if you guys want to be technical, it should be centimeters. I may not do units on some of my problems, so I apologize if I don't. All right, number 4. AD is a median. Find the value of the length of CB. Okay, if AD is a median, then that means it splits this side in half. So this piece equals this piece. So x plus 7 equals 2x minus 15. I need to get my x's on the same side, so I'm going to move my x by subtracting it. The 7 drops, the equals drops, 2x minus x makes x, the minus 15 drops. Trying to get x by itself, I need to move the minus 15, so I'm going to add 15 to both sides, and then I get x is 22. Now, you need to be very careful whenever you take any test to read your directions very carefully. It says find the value of CB, and we haven't done that yet. CB's all the way across, so I need to find a little piece first. So I'm just going to plug my 22 in right there. 22 plus 7 makes 29. So that little piece is 29. So that little piece is 29. So how long would the whole thing be? 58. So CB has a length of 58. All right, first page done. Next page. It wants us to write the trigonometric ratios for the following problems. This is when we're using sine, cosine, and tangent, and we're keeping this pretty simple for you on the test. You don't have to set up any equations and solve. So all you have to know is your memory device, SOHCAHTOA. So if any of you have forgotten what this means, or never paid attention to begin with, the S stands for sine, O is opposite, H is hypotenuse, C is cosine, adjacent, hypotenuse, tangent, opposite, adjacent. So we find sine of something by taking the opposite side and divide by the hypotenuse. We find the cosine of something by taking the adjacent side and dividing by the hypotenuse. We find the tangent of something by taking the opposite side and dividing by the adjacent side. Okay, which of these is the hypotenuse? 26. That's what's across from the right angle. So that's the hypotenuse every time, no matter where you're at. If you're at angle A, still the hypotenuse. If you're at angle C, still the hypotenuse. Okay, so sine is opposite over hypotenuse. Opposite over hypotenuse. It wants me to go to angle A. So I come over here to angle A, and what would be the opposite side? 10 or 24? 24, it's all the way across. So 24 is the opposite side. And then it wants the hypotenuse, and I already know that 26 is the hypotenuse. And then all I have to do is reduce, and I can reduce that. And if I reduce that down, I would get 12 over 13. I just divide both of those by 2. And that is the sine of angle A. Now, if you want to see my calculator reduce, I go 24 divided by 26, and then math, enter, enter, and your calculator can reduce for you. Okay, number 2, tangent. Tangent is opposite over adjacent. Opposite over adjacent. Okay, it wants angle A, so which one's the opposite side? 24, because it's all the way across. And then adjacent means right next to. Well, it's not this one because that's the hypotenuse, so it's the 10 because that one's the one that's right next to it. And then I reduce 24 over 10, divide both of those by 2, and I get 12/5. And that's the tangent of angle A. Okay. Number 3 is tangent as well, so opposite over adjacent. This time, though, it wants me to go to angle C. So I'm over here at angle C, and which one would be the opposite side? Right next to, all the way across. This time the opposite side is 10, because that's all the way across. Okay, and then the adjacent side, it's not the 26, because that's the hypotenuse. It's the 24, because that's the one that's right next to it. So that's one reason why I always label the hypotenuse before I ever begin these problems, so you don't ever think it's the adjacent side. Okay, once again, I can divide both of those by 2, and that would make 5 over 12. And that's the tangent of angle C. Okay, number 4. It wants the cosine. So cosine is adjacent over hypotenuse. Adjacent over hypotenuse. And it wants angle C. So which side's adjacent? 24, because it's right next to it. And the hypotenuse we know to be 26. And I can divide both of those by 2 and get 12 over 13, and there's the cosine of angle C. So that's as difficult as it's going to get for your trig. You don't have to worry about setting up equations or anything. Just know your memory device, SOHCAHTOA. All right, number 6. I want to know the height of the trapezoid. So this represents the height right here, straight up and down, connecting the two bases. This also represents the height, straight up and down, connecting the bases. So I know that the height, the altitude makes a 90-degree angle with the base. If that's 45 and that's 90, then this guy's 45. And this is what I'm looking for. So across from the 45, we label with an X. That would be from here to here. Across from the 45, we label with an X. So these two sides are the same length. They don't look like it, but they are. And across from the 90, we put x square root of 2. Now because there's a number there, I'm going to put an equals between it and the x square root of 2 label. Okay, to solve for x, I have to move the square root of 2. So this is where I divide both sides by the square root of 2. Remember, we can't ever leave a square root in the denominator. So this is when we rationalize that denominator. For my classes, I call it our FFU problems. We multiply by our fancy form of 1. So I multiply by whatever's in the denominator over itself. That's our fancy form of 1, FFU. And then if I multiply straight across, 13 times the square root of 2 is 13 square root of 2. And square root of 2 times square root of 2 is technically the square root of 4, but the square root of 4 is 2. Remember, if you multiply by 2 of the same things under the radical, shoop, out he comes. Now, if I could reduce the 13 over 2, I would, but I can't, so that's it. So this is x, so that's what this guy is. And that is our height. So when it wants to know the height, that's our height right there. 13 square root of 2 over 2. Are you having fun yet? All right, let's keep going. Number 7. Which of the following is not a right triangle? Okay, if something is a right triangle, I need a squared plus b squared to equal c squared. If a squared plus b squared does not equal c squared, then it would not be a right triangle. So remember, c is always the longest side. You don't see the little right angle markings in here, but that's where they would be. And remember, the hypotenuse is always the longest side of the triangle. So I want to see if a squared plus b squared equals c squared. And I don't know, so I'm going to put a question mark around it. Okay, so I'm going to test. Does 3 squared plus 4 squared equal c squared, which is the 5 squared? Well, let's see. And I'm going to use my calculator. So 3 squared plus 4 squared is 25, and 5 squared is 25. So yes, 25 equals 25. So yes, this one is a right triangle. Okay, let's try the next one. I want to know, does 10 squared plus 24 squared, does that equal 26 squared? And I'm going to use my calculator. So 10 squared plus 24 squared is 676, and 26 squared is 676. So 676 does equal 676, so yes, this one is a right triangle. Okay, the next one. Let's see if 7 squared plus 8 squared equals our 9 squared. So check it in the calculator. 7 squared plus 8 squared, and then 9 squared. No. 113 does not equal 81. 113 does not equal 81, so no. Which one is not a right triangle? C is not a right triangle. I could test D if I want to, but I guarantee that D works. Okay, C is the problem. That's not the right triangle. Okay, let's go to the next page. Number 8. It wants me to find the value of x. Now I could do this 2 ways, so I'm going to show you both. This is called an exterior angle, and an exterior angle equals not the one next to it, but these 2 remote interior angles added up. So 2x minus 16 plus x. That's one way of doing the problem. Or the other way to do the problem is that I know that because this is a straight line, that these 2 are supplementary. They form a linear pair, so they add to be 180. So I could take 180 minus my 113 and figure out that this little angle right here is 67 degrees. And then inside of my triangle, I know that the three angles inside of a triangle add to be 180 degrees. So this plus this plus this is 180. So I could say that the 67 degree angle plus the 2x minus 16 degree angle plus the x angle adds to be 180. However you want to work this problem, it really doesn't matter. You get the same answer either way. I just wanted to show you. So either all three angles in the triangle add to be 180, or the exterior angle equals the two remote interior angles added up. I'm going to solve this equation because it's just quicker. So first I combine like terms. 2x plus x makes 3x. I'm going to recopy the minus 16, drop the 113, and then to get the 3x by itself, I'm going to move the minus 16 by adding 16. The 3x drops, the equals drops. If I add 113 and 16, I get 129. And then I would divide both sides by 3. And if I take 129 and divide by 3, I get 43. And that's our x. Okay. Next section. We're trying to figure out why these triangles are congruent, if we can prove them congruent. So we have 5 different ways of doing that. We've got side, 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 angle, side, angle, side, angle, 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 side, the HL theorem, or we could possibly have not possible. It just depends. So looking at this one, tick marks, remember our sides? So I've got the angle between the two sides, so that's side, angle, side. And this is the same thing, side, angle, side. Okay, on number 10, there's something we know about this picture that we need to mark up for ourselves. And that is that these are vertical angles, and vertical angles are always congruent. So now that I've marked that up, let's look at this picture. I've got 2 angles and a side, and the side is between the angles. So that's angle, side, angle. And let's look, angle, side, angle. So number 10 is angle, side, angle. Number 11, I've got vertical angles congruent again, so I'm going to mark that those two are equal. Let's just look at one of the pictures. I've got 2 curves and a tick mark, so that's 2 angles and a side. Is the side between the angles this time? No. So this one is angle, angle, side. Angle, angle, side. Okay, number 12. My angles between the sides, so side, angle, side, side, angle, side. Number 13, I don't have any sides congruent at all. I just have 3 angles equal to 3 angles. So it's angle, angle, angle. But let's look up here. Is angle, angle, angle one of them? Nope. So this is not possible. If all 3 angles are congruent, then that means that the shapes are similar, but that doesn't mean that they're congruent. Okay, number 14. There's something about this picture that we know that we need to mark up. I know that the 2 triangles share this side, so this side has to be the same length in the left triangle as it is in the right. So this side right here is congruent to itself. So I'm going to give it 2 tick marks. Okay, let's just look at this one here. I've got 2 sides and an angle. Is the angle between the sides? Nope. So it can't be this one. And there's nothing else with 2 S's and an A. So let's check for the HL theorem. So is it a right triangle? Yep. Do I have a hypotenuse and a leg? I do. So I have a hypotenuse and a leg congruent to a hypotenuse and a leg. So this is our HL theorem. Okay, number 15. Same situation as 14. This length right here is the same length in both triangles, so it's congruent to itself. And if I just look at one triangle, I've got 3 tick marks, so that's 3 sides. And 3 sides. So those triangles are congruent by side, side, side. And what do you think about 16? What do you think that is? Angle, side, angle. The side is in between the angles, so angle, side, angle. Okay, got one more question along the lines of those kinds of problems. So number 17 says to prove triangle IBG congruent to triangle ATC with theorem side angle side, what information would be necessary if you're given that IB is equal to AT and angle A is congruent to angle I? Okay, let's mark this up. It says that the length of IB is congruent to the length of AT. It says that angle A is congruent to angle I. Okay, I want these two triangles to be congruent by side angle side. So I've got a side, I've got an angle, I need another side. And remember, we need the angle to be between the two sides. So what else would you have to know? You'd have to know that this side would be congruent to this side. That way you have side, angle, side, side, angle, side. So I need IG to be congruent to AC. And C's the winner. Winner, winner, chicken dinner. Okay, I think I'm going to stop here. I think number 17 is a good place to stop, and then I'll pick up another video and we'll do more. Thank you very much. Give you a little smiley face for your journey so far.